Assalamu alaikum wa rahmatullahi wa barakatuh. So making this video as a replacement of the class that we missed yesterday. So it's going to be about chemical formulae, as you can see, about mole concept, and about calculations. And majorly, it will deal more on calculations than the rest that we see over there. So without wasting much of our time, let's go ahead, please. So the first, here we need to know what relative molecular mass is. As you can see, it is the um, it is mass. It is the relative mass of one molecule. That is, relative molecular mass of a compound is the relative mass of one molecule of that compound on a scale where carbon-12 isotope has a mass exactly 12 units. So the definition can be explained further, but for the purpose of this class, we don't really need the definition. We will go ahead into the calculation part. But before we get there, let's look at some concept before we go into calculation. So as you can see here, we want to learn how to calculate that relative molecular mass. So we can find the relative molecular mass by adding up the relative atomic masses of all the atoms present in the molecule. For example, we have methane molecule here. So methane has carbon atom, one carbon atom and 4 hydrogen atoms. So we can say one carbon atom and 4 hydrogen atoms. So I said we will find relative molecular mass by adding up the relative atomic masses of all the atoms present in the molecule. So we have only 2 types of atom present here. So what is the relative atomic mass of carbon? If you check the periodic table, it is 12. And for hydrogen, of course, it is 1. And how many carbon atoms do we have here? We have 1 carbon atom. So when we are doing the calculation, if you want to find the MR of methane, MR of CH4 will equal to 1 carbon atom times the relative atomic mass of carbon plus number of hydrogen atoms, we have 4 of them, multiplied by the relative atomic mass of hydrogen, which is 1. So in this case, our answer is going to be 12 plus 4, which is 16. So don't forget that relative atomic mass does not have unit. I think I told you before, because we are just relating the mass of a substance or of a compound to the of an atom or a compound to the mass of that of carbon-12. So we are relating mass to mass. It's like you are dividing mass by mass. So that is why we are not giving any unit to relative atomic mass. So that is the example of calculating relative atomic mass of methane. You can use this method to calculate relative atomic masses of any other atom. So let's go further to look at what we mean by relative formula mass. I think we discussed this one in the past before. So when we said relative formula mass, just same thing as relative atomic mass. But in this case, we are talking about the compounds that contain ions. So for example, carbon dioxide is a molecule. So this one does not contain ion, but sodium chloride is an ionic compound. So it contains sodium ion and chloride ion. So another example is sodium hydroxide, which contains sodium ion Na plus and OH minus. So these compounds like this, we use relative formula mass to represent them. We don't say relative molecular mass because they are not molecules. But the unit and the the units, and as well, if it doesn't have any unit anyway, the symbol is going to be the same thing. And so there's no difference between relative molecular mass of and relative atomic mass. So we are just dealing with compounds of different type, either molecular compound or ionic compound. But everything is going to be the same. If we're going to do the calculation now, we'll have the same way of doing the calculation. So if you look at this example, we are calculating the relative formula mass of magnesium hydroxide. So the formula of magnesium hydroxide is MgOH bracket 2. So it means we have three types of atoms here. We have one magnesium atom, we have two oxygen atoms, and two hydrogen atoms as well. So we're going to add these together. So we can just go further and say 1, the relative atomic mass of magnesium is 24. For oxygen, there are two atoms, and the relative atomic mass of oxygen is 16. For hydrogen, we have two atoms of hydrogen, and its relative atomic mass is just 1. So if you add up all this together, it's going to be 24 plus 32 plus 2. So let's do the addition together. We have 8 here, and then we have 5. So the relative atomic mass of magnesium hydroxide is 58. Let's look at it again. So 4 plus 2, that is 6, plus 2, that's 8, 5 plus 2 plus 3, that's 5. So it is 58 grams. Okay, so that is how to calculate relative formula mass and relative molecular mass. As I said, they are just the same thing, the same way of doing the calculation, and even the symbol is the same. So I have these questions for you. I want you to try them. But when you are number A, B, and C, they're not that difficult. But this one, when you see something like this dot here, so what you're going to do is just that you will calculate the relative formula mass of magnesium nitrate, and then you calculate that of water. You remember we have 6 molecules of water here, so you calculate that of water, 6 molecules of water, and then you add them together. Add for this, add it to this. So this dot is just like addition when you're calculating relative formula mass of this compound. So that is how to do that number D. So let's go ahead without wasting much of our time. So we want to look at the mole and the Avogadro's constant. So in everyday life, we use counting units such as dozen, for 12 objects, we can say 1 dozen, which if there are 12 of them, you can say 1 dozen, like 1 dozen of pencils. So it means we have 12 pencils. Or we say 24, if we have 24 pencils, it means there is 2 dozens. Okay, and we also use score. If you remember, score means 20. If you have 20 objects, we can say score. Gross, if you have 144 objects, we can use gross for it. So, and so on and so forth. So in chemistry, the counting unit for numbers of atoms or ions or molecules in the laboratory size sample is the mole. So if you want to count units, if you want to count for number of atoms or number of ions or molecules in the lab, we use mole to do that. So as we have here, when we say mole, 1 mole is the amount of matter that contains as many objects as the number of atoms in exactly 12 grams of carbon-12 isotope. So from experiments, this number of atoms in exactly 12 grams of carbon-12 isotope is 6.02 times 10 to the power of 23. And this number is called the Avogadro's constant. or we call it Avogadro's number, and it is represented by this symbol, which is N of A. It is often cited with units. Sometimes they put units into it. Sometimes we don't put unit. But when we put unit, it is per mole. That is 1 over mole. That is the unit of Avogadro's constant. So let's look at this. This is very important, this relationship. If you have 1 mole of an object, so think of you have 1 dozen of pieces of pencil. So when we say 1 dozen of pencil, as I mentioned last time, so when you are trying to count each, how many pencils do you have in 1 dozen? You are going to have 12 pencils. So when we have 1 mole of an object or anything, if you try to count, for example, you have 1 mole of rice. If you try to count the grains of rice in that 1 mole, it will be 6.02 times 10 to the power of 23 grains of rice in that 1 mole of rice. So as you see it over here now, if you have 1 mole of carbon 12, it will contain 6.02 times 10 to the power of 23 carbon atoms. You have 1 mole of water molecule. Remember, we said water molecule. So it means we are going to have this number of molecules of water inside that 1 mole. If you have 1 mole of nitrate ion, it will contain this number of ions inside it. So please take note of that. That is very important. We are going to use that relationship in our future calculation.